in 9C, we're actually looking at where the power is negative. So let me just get that up. So when we're differentiating a term, but this time n is a negative integer, so a negative power. So we still use the same rules, okay? So when your function is x to the power of n, what we do is decrease that power, all right? So n minus 1, and multiply the coefficient by whatever that power was originally. And the constant still equals 0. Okay, so same rules apply. I might need to make this a little bit bigger so we can see the questions. All right, so for question A, I might just write the function down. So we've got 3x to the power of negative 2 plus 5x to the negative 1 plus 6. All right, so your derivative, so we're just looking at each term individually. So we still take the power and multiply it by the coefficient. So negative 2 times 3 is negative 6. So negative 6x, and then we decrease negative 2 by 1. So it's going to become negative 3. All right, well then for 5x to the power of negative 1, we take that negative 1 and multiply it by the 5. So it's going to be negative 5x, and then we decrease the power by 1 again. So it's going to be negative 2. And then our constant just becomes 0. All right, so just tidying that up, you could probably do that without writing it again. So we've got plus minus, so it's going to be a minus 5x to the power of negative 2. So that's your gradient. Now for part E, we did one very similar in the previous video. So just looking at making it a bit simpler by, all right, so there's our function, our equation. So just taking out x, or we could take out, don't really need to take 2x out. Let's, I'll just take out x as a common factor. So we've got 4x plus 2, sorry, I'm just thinking as I'm writing, over x squared. Now that x will cancel out with one of those x's. You know, sometimes as I do things like this, I just think, oh, I probably could have done that an easier way. So that's over x. So I still have a term in the numerator and a term in the denominator. Now, you should know that x, so 1 on x is the same as x to the power of negative 1. So I can take out x to the negative 1 up the top, put it up the top, and multiply it by 4x plus 2. So when I multiply that through, x to the negative 1 times 4x just becomes 4. And then I've got plus 2x to the negative 1. All right, because when you're multiplying terms, your powers are added. So negative 1 plus 1 just gives you 0. So x to the power of 0 is 1. So that just leaves you with 4. So 4 plus 2x to the negative 1. All right, so our derivative, God, I've taken up a lot of space. All right, so the derivative of 4 is 0, then the derivative of 2x to the negative 1 is negative 2x to the negative 2. All right, so we're just multiplying that coefficient of 2 by negative 1. So that gives you negative 2, and then we decrease our power by 1, so negative 1 becomes negative 2. All right, in question 6, find the gradient of the tangent to each of the following curves at the stated point. So I might just do one question, and we'll do D, because usually the last one is a bit harder. So we've got y equals x times x negative 1 plus x squared minus x to the negative 3. Now it says x does not equal 0, and we're finding the gradient at 1, 1. All right, so we've got 1, 1. All right, so let's just expand that first. So this is x to the power of 1. So x to the power of 1 times x to the negative 1 gives you x to the power of 0. And I'm going to write that there so we don't forget. All right, I'll explain in a sec. Okay, it doesn't cancel out your x's. It's x to the power of 0. All right, x to the power of 1 times x to the power of 2 gives you x to the power of 3. And then x to the power of 1 times negative x to the power of negative 3 gives you x to the power of negative 2. All right, so just adding your powers. So 1 plus negative 1 is 0, 1 plus 2 is 3, and 1 plus negative 3 is negative 2. All right, so your derivative. All right, so actually the reason I wrote x to the power of 0, because we've got to remember that's 1. All right, but when we take the derivative of 1, that disappears. All right, so basically when we multiply that by 0, it becomes 0 anyway. So then we focus on x cubed, so we're going to have 3x squared as our derivative, and then x to the negative 2 times negative 1 is 2, so we've got 2x, and then we're going to decrease our power, so it's going to be negative 3. Now we want to find the gradient of the tangent at a certain point, so at x equals 1, so let x equal 1. So we're going to have dy dx is equal to 3, 1 squared plus 2 times 1 to the negative 3. All right, 3 times 1 squared, so 3 times 1 is 3. And does not matter that it's a negative power because 1 to the power of anything is still going to be 1, so it's 3 plus 2, so your answer is 5. All right, a nice short video there because you should have the skill, I think so, yeah, you should have the skills to do the questions that I didn't do. But have a go at doing them, it's good practice. All right, bye girls.